Hi guys, it's one and only maths and physics based teacher. So on this session, we'll be dealing with Kirchhoff's laws. So they are saying calculate the current in each branch in the circuit by using Kirchhoff's laws. Also calculate the voltage and the current flowing through the R5 resistor, right? So when you look at the circuit that we're given here, we're gonna apply Kirchhoff's laws, right? But the first thing that basically you must understand as we're going to apply Kirchhoff's law, so we must first calculate the unknown current at BD, calculate the unknown current at DE, as well as calculate the unknown current at CE in terms of I1, I2 and I3. So those are our first starting point. So what we are going to basically do from here, it's now us calculating those unknown currents, right? So for us to calculate the current at junction BD, so we know that when we look at the current at BD, so we don't have the current at BD, but we know the current that is entering, which is I1, as well as that is leaving, which is I2, right? So the current that is leaving is going to be I2 as well as I at BD right there. So what we are going to do, we're just going to say I1, right? It's equals to what? It's equals to us having I2 plus the current at what? At BD. Now we can determine the current at BD, right? So we're going to say what? We're going to say I1 minus I2 is equals to the current at BD. So we are now having the current at BD being I1 minus I2. And then you can write it and say therefore the current at BD it's equals to I1 minus what? Minus I2. So that's our current. And then after determining it, if you want, you can just go to the diagram and try to make sure that you write it right. And then from here, okay, let me try to maybe increase my annotation for the sake of those who might not be able to see. Now we're gonna calculate the current through what? Through CE, right? So we know that the current that is entering is gonna be current at, you can also do it like this and say current at BC is gonna be equals to the current that is leaving, which is gonna be the current at what? The current at CD plus the current at what? The current at CE. So the current at BC, we are having it being I2 right there when you look at the diagram, closer to resistor number 1 there. So we're having I2, it's equals to, so the current at CD is I3 if you check it properly, plus the current at CE. So we're gonna say therefore the current at CE is gonna be equals to what? It's gonna be I2 minus I3, right? So that's what we are basically having right there. Now after now being able to do what? After now having that, we can now do what? We can now calculate the current through DE, right? So the current through DE, you can just say we can say the current through BD, we can get it as follows and say the current through BD, right, plus I3 is equals to the current at DE, right? And then the current through BD, do you have it? Yes, we are having it. It's gonna be I1 minus I2, the one that we got above, plus I3. That will give us what? The current through DE. So now I'm now having what? I'm now having the current through BD, which is going to be I1 minus I2. I'm now also having what? The current through CE, which is the one that I got being I2 minus I3, as well as now I'm having the current through DE, which is I1 minus I2 plus I3. So it means that now I can basically start with my answers for determining the Kirchhoff's law. Now with regards to that, I'm gonna use this one, which is the current through BD, I'm gonna use that one, which is the current through CE. I'm gonna use this one, which is the current through DE. Now the next step from here, what I'm going to basically do is now to determine what it's now determining what we call our loops, right? So I'm forced to use the next slide. So we're just gonna say consider the loop. Remember, with regards to the loop, you can choose any loop that you best prefer. So I'm gonna start with my loop A, B, C, D, E, F, A. So that is my loop, right? Then we know that here we are having our battery there, our voltage, which is 30 volts, right? So we're gonna use one of the laws for Kirchhoff, which we know that is gonna be 30. It's equals to what? It's gonna be R1 multiplied by I2, and then plus R5 multiplied by R3, I3, plus it will be what? It will be R3 multiplied by the current through DE. Now here, what you need to understand is that you need to substitute the current through DE that we recently got here, right? As well as now substituting the resistors that you are having. So here we're gonna have 30, it's equals to, so our resistor number 1 is gonna be a 40 ohm resistor. Then we're gonna say I2, right? Plus, and then when you look at R number 5, the 50 resistor there, it's a 50 ohm resistor. You're gonna write 50 ohm I3 plus, and then our third resistor, if you check it properly on the diagram, it's also 50 ohms. So you're just gonna say 50 into, and then the current at BD at DE. So to say, we got what? We got I1. We're gonna substitute I1 minus I2 plus I3. So the next step here is just to multiply throughout to destroy the bracket. So you're gonna have 30 equals to, that is 40 I2, right? Plus, that is 50 I3, and then that will be plus 50 I1 and minus 50 I2 plus 50 I3. So the next step is to simply do what? Pair like terms, right? So like terms, these are terms which look alike, or these are terms which carry the same variable. So this one of 40 I2, I'm gonna pair it with a negative 50 I2, right? And then this one of 50 I3, I'm gonna pair it with this one of 50 I3. Do you see? So on the next step, what am I gonna do? On the next step, I'm just gonna write 50 I1, and then the green one's 40 minus 50, that's gonna be negative 10 I2, and then the blue one's 50 I3 plus 50 I3, that's gonna be what? Plus 100 I3. So that on its own, it's gonna represent our equation number 1 on our loop, right? And then after this, I'm gonna now use the second loop, which is us saying consider the loop. So here we're gonna choose our second loop, which is gonna be A, B, D, C, E, F, A. So that is our loop. And then after having that loop, we're now gonna apply Kirchhoff's law, right, on that loop. So we're gonna have 30, it equals to what? R2, and then the current at BD, and then plus into. Now, just because of our current I3 is in the opposite direction, we are forced to put the negative sign. So that will be negative R what? R5 I3, and then plus our R4 multiplied by the current through CE. So it's always encouraged to substitute from the original formula so that you don't make mistakes. So it's gonna be 30 equals to, now our R2, we are given a 20 ohm resistor into, now when you check the current at BD, so the current at BD, what are we having? That is I1 minus I2. That is the first one there. I1 minus I2. So you'll write I1 minus I2, right? And then positive times negative, we know that is gonna be negative. and then our R5 resistor, we can just write it for the sake of others, just write minus, right? And then our fifth R5 resistor, it's a 50 ohm resistor, so you can just say 50, right? And then we say I3, and then we're gonna say plus, and then our R4, it's represented by the 40 ohm resistor, so you're gonna say 40 into what? The current through CE, it's I2 minus I3, so you'll say I2 minus I3. So from here you're gonna say 30, it's equals to, and then 20 times I1 is gonna be 20 I1, then 20 times negative I2, that will be negative 20 I2, and then here we're gonna have minus 50 I3 plus 40 I2, and then we're gonna also have minus 40 I3, right? And then from here, what you basically do, you are gonna pair like terms. So this one of negative 20 I2, it goes hand in hand with this one of 40 I2, right? And then this one, which is negative 50 I3, it's gonna go with that one. So you must make sure that you pair them nicely. So with that being said, what are we gonna have here? We're gonna have 30, it's equals to what? It's gonna be 20 I1, and then plus 20 I2, because negative 20 plus 40 is gonna be 20 I2, right? And then minus 50 I3 minus 40 I3, it will be what? It will be minus 90 I3. So that on its own, it's gonna be representing our second equation, which is equation number 2. Now after writing that, we are now gonna find our third loop, right? So we're gonna write our third loop. So as long as you write them the way I'm writing them, you can't be wrong. So that's why I'm encouraging you to circle the like terms. So our third loop is gonna be us saying consider the loop. So that is the loop that we're gonna consider, which is loop A, B, C, E, F, A. So that is our loop there. And then what we are going to have, we're gonna have 30, it's equals to, then it will be R1 in combination with current number 2, right? Plus we're gonna have R4 in combination with the current through CE. Now let me show you this loop that I've just recently wrote now. Now when you look at that loop, it's gonna be this loop here. Let me just show you. Remember, it's loop A, B, right? C, right? After C, it's gonna be E, F, A. So we're having R1, I2, so let's R4, the current through CE, right? So that is the loop that I just recently showed you now. So you must make sure that you don't do mistake. And then after that, now what you are going to do is now simply doing what? It's now simply substituting. So that will be 30, it's equals to, so R1 is represented by the 40 ohm resistor, I2, right? Plus, and then R4, when you look at the diagram, it's also represented by the 40 ohm resistor, into. Now the current through CE, we got it on the first slide, which is going to be I2 minus I3. Now the next step here is to just multiply and destroy the bracket. So we're going to have 30, it's equals to, so that is 40 I2 plus, that will be 40 I2, and then that will be minus 40 I3, right? So here we're going to have 30, it's equals to, now here when you look at these two, we're going to add like terms, right? So it's going to be 40 I2, when we add it with 40 I2, what are we going to get? That will give us 80 I2. So we're going to write 80 I2 minus 40 I3. That on its own is going to be representing our equation number 3. Now the tricky part about using Kirchhoff's laws is that one mistake if you can make a mistake with a negative sign or a positive sign, then everything is gonna be wrong, right? So you must make sure that when you solve these questions, you don't rush, you just do what you are supposed to do. Now, one thing that we are going to do after getting those three loops, which is gonna be our loop, we must have our fourth equation. Now, how are we gonna take our fourth equation? So our fourth equation, it means that we're gonna write equation 1 as it is. Let's now write equation number 1 as it is. So we're gonna write equation 1 as it is. So equation 1 is represented by 30. It's equals to what? It's equals to 50 I1, right? And then minus 10 I2, right? And then plus 100 I3. So that equation, it means that we're gonna do what? We're gonna multiply by the first by the what? We're gonna multiply by the first coefficient that we are seeing on this equation right here, which is 20. So we're gonna multiply it by 20. So we're gonna say times 20. So that is the first step that we are going to do. Now when you multiply that, it's gonna be 30 times 20. That should give you 600. It's equals to then 50 I1 times 20. You're gonna get 1000 I1, and then negative 10 I2 times 20. It's gonna be negative 200 I2, and then plus 100 I3 times 20. That will be positive 2000 I3, and then this on its own, it gives us equation number 4. Now after getting equation number 4, remember you must get another equation, right? So we're gonna write equation 2 as it is. So our equation 2, it's represented by what? Let's check. Our equation number 2, it's represented by, let's write it as it is. It's gonna be 30. It's equals to, it's gonna be 30. It's equals to what? It's equals to 20 I1, and then plus 20 I2, right? Minus 90 I3. So this equation that we are seeing here, we're gonna multiply it by this coefficient here. So we're gonna multiply by what? By 50. Multiply by 50. Now here we're gonna have around 8 steps or 8 equations, so you must be very careful. Now 30 times 50, we're gonna get 1500. So that will be 1500. It's equals to 20 I1 times 50. That's 1000 I1, and then 20 I2 times 50. That's gonna be plus 1000 I2, and then here we're gonna have minus 90 I3 times 50. It's minus 4500, and then I3. There on its own, we are on equation number 5, right? Hope you are following. So you must make sure that you follow all the steps that I'm just showing you. Here you saw that, remember, we were getting loops. Now we are busy with getting our equations, right? And then after that, remember on the previous step, we got 1500 is equals to 1000 I1 plus 1000 I2 minus 4500 I3. Now here, it's a matter of now subtracting equation 5 minus equation number 4. So we're gonna say equation number 5 minus equation number 4. So if you want to say equation number 5 minus equation number 4, you can basically write it if you want. So our equation number 5, so equation number 5 is going to be 1500. You can write it like this. It's equals to, so it's going to be 1000 I1 plus 1000 I2 minus 4500 I3, and then we're gonna subtract our equation number 4, which in this case is gonna be 600 is equals to what? That's 1000 I1 minus 200 I2 plus 2000 I3. So remember, here we are basically subtracting, right? So 1500 minus 600, what are you gonna get? You're gonna get 900. So that 900, you're gonna simply write it here. 900, it's equals to, so 1000 I1 minus 1000 I1 is gonna be 0, you know. And then 1000 I2 minus 200 is gonna be plus what? Plus 1200 I2, and then minus 4500 minus into 2000, that's gonna be minus what? 6500 I3. So when you write this properly, you can write it as what? As 900, it's equals to 1200 I2 minus 6500 I3. So this is our equation number 6. So after getting our equation number 6, we're gonna write, was that equation number 3? Yes, you take equation number 3, see this, you write it. It's gonna be 30, it's equals to what? 80 I2 minus 40 I3. Now this equation, what are we gonna do? We are gonna multiply by 1200, right? So when you multiply by 1200, what do I get? 30 times 1200 is 36,000. So you're gonna get 36,000. It's equals to, now 80 I2 multiplied by 1200, that's 96,000 I2, and then minus 40 I3 times 1200 is minus 48,000, and then that will be I3. That on its own, it's our equation number 7. And then from here, we're gonna take that equation that we recently got, which is 900, and 900, it's equals to what? It's equals to 1200 I2 minus 6500 I3. We're gonna multiply it by what? We're gonna multiply it by 80. So as we multiply it by 80, here it will be 900 times 80, that's gonna be 72,000. It's equals to, then 1200 I2 times 80 is gonna be 96,000, and then I2, and then negative 6,500 I3 times 8 is gonna be what? It's gonna be minus 520,000 I3. So that is equation number 8. And then after getting that equation, we are now gonna subtract and say equation number what? Equation number 8 minus equation number 7. Now there is no need of you writing it like how I wrote it here, but if maybe you don't understand, you can also write it the way I wrote it here. So I was just doing it for the sake of you to understand. Now that you know, when you say equation number 8 minus equation number 7, remember it will be 72,000, right, minus what? Equation number 8 minus equation number 7. So it's gonna be 72,000 minus 36,000. So there, what are we gonna have? We're gonna have 36,000. It's equals to, now look at this here, you're gonna say 96,000 I2 minus 96,000 I2. In matter of fact, they're gonna cancel out, right? So it will be minus 520,000 I3 minus into negative 48,000. What are you gonna be left with? You're gonna be left with minus 472,000 I3, right? And then from here you want I3, you divide by negative 472,000, divide by negative 472,000, right? And then this cancels that. You now know that here you're gonna have I3, so you can write it like I3 it's equals to, that should be 36,000, all divided by minus 472,123. So our I3, which is our current number 3, is gonna be represented by negative 0.076 amperes, because that is current, and then current is measured in amperes. Now one thing that is very important from here is that after getting your current, you're gonna do what? You're gonna now say, you're gonna also always substitute, you're gonna always leave your answer, so to say, in 3 decimal places. That's one thing that I wanted to say. So after getting your answer, always make sure that you round it to 3 decimal places, right? And then the next step that I'm gonna do, I'm just gonna say substitute I3 into what? Into equation number 3. So the reason now we choose equation number 3 is because equation number 3 is the one that has 2 unknowns, so you can solve the other one. So our equation number 3 is 30 is equals to what? It's equals to 80 I2 minus 40 I3. So here we're gonna say 30 is equals to, so that will be 80 I2 minus 40 into, now you can see that our I3, we recently got it being negative 0.076 amperes. Now we can calculate second current, which is I2. So here we're gonna have 30, it's equals to what? 80 I2 plus, because negative times negative is gonna be positive, right? And then 40 times 0.076, that's positive 3.04. Then from here you're gonna say 30, you take negative 3.04 to the other side, it's gonna be minus 3.04, it's equals to 80 I2. Then now you subtract 30 minus 3.04, that's gonna be 26.96, it's equals to 80 I2. And then from here, if you want the second current, which is I2, divide both sides by 80. Then 80 cancels 80, and then I2 it's equals to 26.96, all divided by 80. Therefore our I2, which is gonna be the second current there, remember you write it in 3 decimal place, it's gonna be 0.337 amperes. Now you are having what? Now you are having the second current, also having the third current. Now you can solve current number 1 by just saying what? By saying substitute I2 and I3 into what? Into equation number what? Into equation number 2. So as we write our equation number 2, now our equation number 2, it says 30 it's equals to 20 I1 plus 20 I2 minus 90 I3. So you're gonna say 30 it's equals to 20 I1 plus, then that will be 20 into, now our I2 is represented by what? By 0.337, right? And then we're gonna say minus what? Minus 90 into what? Minus 0.076. So from here what you can basically do, you'll say 30 is equals to 20I1, and then plus 20 times 0,337, it gives you 6,74. You write it as it is. Then negative times negative, it's positive. Then you say 90 times 0,076, that's 6,84. 6,84. Then here we're gonna say 30 it's equals to 20I1 plus, then 6,74 plus 6,84, it gives you 13,58. So you write 13,58, and then you're gonna say 30, you take 13,58 to the other side, it will be minus what? Minus 13,58 is equals to 20I1. Then you're gonna now subtract 30 minus 13,58, that's gonna be 16,42. 16,42 is equals to 20I1. From here you do your maths. Divide both sides by 20, because maths or science says what you do on the left hand side, you must also do it on the right hand side. Then what's going to happen here, you know that 20 will cancel 20. Then you'll be left with the first current, which is I1, which is gonna be 16,42 divided by 20, and then I1 you're gonna get 0,821. 821, that is current that should be measured in amperes, right? And then after that, what you're going to do, remember when you check, okay, let me do, for the sake of space, there's something that I want to show you. Let's go back to what they told us to calculate. They said calculate the current in each branch, right? So the current in each branch is the first one, which I represented with the star, with the second star as well as the third star. So the current through each branch, it is the current through BD, it is the current through CE, as well as the current through DE. Now you write all those currents, right? So our first one is gonna be the what? The current through what? Through BD. It's gonna be represented by I1 minus I2. Now for you to get the current through BD, it's a matter of you now substituting. You have your current, which is I1, which is gonna be 0,821. 821 minus 0,337. Therefore, the first current, which is the current through BD, is going to be represented by what? By 0,484. Current is measured in amperes. And then our second one, which is the current through the second branch, which is the current through what? Through CE, is going to be represented by what? By the second current subtracting the third current, which is I3. Then from here, you know that the current through CE is gonna be equals to, now when you check I2, it's gonna be 0,337 minus our I3 is negative. You substitute it as it is. It's gonna be minus 0,076. Then our current through CE is gonna be equals to what? It's gonna be 0,337. Remember, negative times negative is positive, right? 0,076. Then therefore, the current through CE, you add 0,337 plus 0,076. Therefore, the current through CE is going to be what? 0,413. So current is measured in amperes. And then after that, we now calculate the last current, which is the current through DE. So you can just say the current through DE, it's equals to, remember it's represented by I1 minus I2 plus I3. So our current through DE, it's equals to, now you substitute, right? So our I1 is going to be 0,821 minus our current through I2 0,337, and then plus into our I3, remember is negative, so it's going to be negative 0,076. So our current through DE, we're going to get what? We're going to get 0, when you punch everything on the calculator, 0,408. Remember it's current, it must be in amperes. Now when you go back and again to the question, they said after calculating the current through each branch, also calculate the voltage and the current flowing through the R5 ohm resistor. So the R5 ohm, when you check it, the R5 resistor there, it's going to be the 50 ohm resistor. Now the current is going to be what? It's going to be I3. So this is the current, do you see, which is I3. Now we know that they said what? Calculate the voltage, yes, and the current through R3. Now we're going to calculate the voltage through the R5 or the 50 resistor there. So what we are going to do from here, we know that our I3, because why am I using I3? I'm just using I3 because I3 is the current that is going through R5, which is the one that they wanted us to do what? To basically calculate, right? So our I3, what did we get? So our I3, we got negative 0.076 amperes. Now that negative, it represents direction of the current, to say the current is going the opposite direction, right? Now, since they want us to calculate the voltage across the 50 ohm resistor, this is what you're going to do. You can just write it as follows and say voltage across the 50 ohm resistor, because the 50 ohm resistor is the one that is represented by R5, right? So how are you going to calculate that? You're going to say V is equals to IR, right? And then you can also say the voltage through R5, it's equals to, our current through R5 is going to be I3 if you check it properly, and then multiply by R5. So our voltage there through R5 is going to be our I3. Remember now, since we're calculating the voltage, it can never be negative. So that negative on the current on the I3 represents the direction. So you substitute it as positive. So hence it's going to be what? It's going to be 0.076 multiplied by what? Multiplied by the 50 ohm resistor. Because when you check the diagram, let me show you. When you check the diagram, our 50 ohm resistor is this one, which is R5, and then it's in combination with I3, right? So that negative, it should not stress you. So here I can say therefore what? Therefore the voltage, it's going to be what? When you multiply 0.076 times 50, it's going to be 3.8. So it's going to be 3.8 volts. Now 3.8 volts is our voltage through the R5 resistor, which is going to be the 50 ohm resistor. Now that negative, as I've just elaborated, is voltage, right? And voltage can never be negative, so we must omit the negative sign. So if you want to write it properly, you can say therefore the voltage through the R5 resistor let me write it here, through the R5 resistor is gonna be what? It's gonna be 3.8 volts, just like that. So guys, this is the calculations that you needed to do. This is how basically we use Kirchhoff's laws. Now Kirchhoff's laws, it's one of those important questions that you must understand. That's why you can see that here we ended up having 8 equations on this particular question. It was one of those interesting questions, and it's very important that basically you know how to use it. It's one and only favorite maths teacher. Stay tuned for more.